An Ergonomic Perspective on Human-Computer Interaction by Lacey, Burnette, and Tori McDaniel. Human-computer interaction is the analysis of computer design and use with specific focus on the interface between people and technology. The underlying ergonomic concerns with HCI include issues of user well-being, system effectiveness, and productivity, with the accelerating development of human-computer interaction systems for users not trained in computer science. The effectiveness of the user-computer interface has become increasingly important. As a result, ergonomic research has focused in three main areas of human-computer interaction: physical, social, and cognitive. Physical elements of concern for ergonomists include musculoskeletal disorders and repetitive strain injuries. In order to combat the physical hazard of HCI, ergonomists research the biomechanics of input devices and physical computer layouts. One socio-technological concern is the concept of a developer's embodied position. The argument is, as technology takes hold, then it becomes very difficult for an individual to override the values driven by the technology. For example, the design and deployment of passenger-side front airbags have, in a sense, held children hostage in the back seat of millions of cars. Also, the social norms implicated in real-world interaction must be considered when designing HCI systems. It is essential to ensure the psychological welfare of the end user. The connectivity of HCI allows for a new sector of human interaction via webcam and FaceTime. But with these benefits also comes a societal impact ergonomists need to understand in order to consider user well-being. Lastly, cognitive ergonomic research is used in HCI to understand how the human mind instinctively interacts with these systems. Cognitive ergonomists consider what knowledge is required by the human to effectively work with user-computer displays.
The first user-computer interface was comprised of punch cards to batch processing machines. These cards contain instructions or data that were coded by the user through the presence or absence of punch holes in specified locations. Although these systems were considered advanced at the time, from an ergonomic perspective, they were not effective, because processing times could span into entire days. Also, the batch machine could not accommodate for user error. For example, a missed punch could result in the disruption of an entire program. Additionally, these systems required extensive knowledge, which resulted in a high learning curve and limited the number of users. The next phase of user-computer interface came about in the late 1960s with command line interface. This greatly reduced processing times and allowed the user to change his or her commands based on feedback. With the evolution of precise commands, human-computer interaction became more flexible and accurate, thus increasing usability. However, command line interface still required the knowledge of specific language and terminology, which also contains a large learning curve and still limited the number of users. The next phase of development was the graphical user interface, which was introduced in 1984 with the personal computer. It allowed users to interact with electronic devices through graphical icons and visual indicators. The design of the graphical user interface embraced ergonomic principles and made computers accessible to the general user. The coding, conceptual, and spatial principles of visual displays have been incorporated into the graphical user interface to reduce the user's learning curve. Some examples of these principles being used are print icons, start menus, hover descriptions, pop-up menus, and many others. As designers continued to create products that were increasingly user-friendly, the focus shifted to programs which designed out errors, resulting in tools like spell check and auto-tune. The next step in the evolution of the user interface design is the natural language interface. Natural language interfaces allow the user to communicate with the device in the same way he or she would communicate with another human. The device subsequently translates the information into a command that it understands. With this, the human no longer has to adapt to the device, but rather the device adapts to the human. It removes the learning curve. Natural language is often used in search engines to interpret what the user is looking for. If a user entered the company name Starbucks into a traditional search engine that has spell check functions, the search engine is likely to assume that the user made a mistake and searched for keywords star and bucks. Yet, if the user entered the same input into a natural language search engine, it would likely understand that the user is wanting a cup of coffee and return coffee shops near his or her location. As human-computer interaction advances, research has transitioned into a new era. Artificial intelligence, also known as AI. AI is used to increase the intuition of current human-computer interfaces. MIT scientist Henry Lieberman explains, human-computer interaction interfaces can use artificial intelligence techniques to recognize the user's intent implicitly, so they don't have to provide explicit menu or icon operations for every single thing the user might want to do. Another aspect of AI is the development of interfaces for artificial intelligence platforms, which are currently in the test phase. The primary example of an AI interface is Pepper, the interface of IBM's Watson. Although AI has faced some resistance, this human-computer interaction advancement has proven to be quite the milestone. From an ergonomic perspective, artificial intelligence applications exist in areas which are hazardous to humans, such as space and deep-sea exploration. They also provide capabilities beyond human cognitive function that can supplement humans in the decision-making process. The possibilities and limits of artificial intelligence are currently unknown, but will change the state of human-computer interaction.